I do have a quick question. When you're finding FE and it's n minus n.
Okay, we're going to do the whole thing from scratch that we did yesterday. It was a good review. Hopefully it'll go a lot quicker today. So go ahead and open up that same spreadsheet we had open yesterday in Excel. And it's worksheet 14.1. We're just going to start from scratch as if we're starting over. And hopefully you guys did pretty good yesterday. We're going to answer this. So let's pick on Mitch. How do I make a scatter plot?
Highlight X, highlight Y.
Like separately?
Yeah.
Well, it's going to be interesting. I wouldn't have done it that way, but we'll see if it works. Okay?
Insert.
Insert. Scatter. Yeah, it worked. I would have just highlighted them all together. You didn't need to separate them. But that's fine. So how do I add the titles?
Add chart element or that plus.
Click the plus sign, access titles. That's a lot easier. Okay, and then what? What is this?
That is your
Age. And this is
cholesterol.
And age versus cholesterol.
How do you get the cost without the connecting lines?
Without the connecting lines? I did a scatter plot, not a line chart. A line chart will give you lines. Did you do scatter?
I got a scatter, but it connects all the dots for me.
Well, so this here, we'll do it again. Okay, I would just highlight the whole thing like this, insert, scatter, pick the first one. If you pick this one, it'll add lines. Yeah, don't pick that one.
Recommended scatter.
Oh, yeah, see, then, yeah, don't do the recommended. Excel doesn't know what you're doing. All right, so add these back in. Age, cholesterol, age versus cholesterol. Okay, so now, Marin, how do you find the correlation coefficient quickly and easily?
Equals
Coral. And then what? Grab the X's, and then grab the Y's. Okay, that's where you need to separate them. Okay. So I got 0.717, and that is, what is it? Strong, moderate, weak, or none? Strong correlation because greater than what? 0.7. Okay. All right. So now, how do I find the OLS equation, Gabriel? Oh man, we were going along fine there. We messed this up.
I know.
Kendall, how do you do it?
You just click on the graph and go to that plus side.
Oh, you guys always click on the plus sign. Don't click on the plus sign. I'll go here faster. Pick a point, any point, and then say add trend line, and it'll put that all there for you. It's faster. But I know you guys like to spend all that time in the testing center, so you can do it the slow way. That's fine. You can find the R squared and the equation just like that. See, I'm faster.
So is the purpose of finding the correlation coefficient just so you can know how strong the correlation is?
Yes. Okay.
You'll want to do that every time.
Now, probably if I'm doing a regression, probably. Was there a question, Jaden? What does R squared tell you? Gentry, what does it tell you?
Your regression squared.
Not your regression squared. Not your residual squared. That's a residual, but what's R squared? Percentage of the variation that's explained by what? By the model, by the equation, yeah. We call the equation a model. Okay? So what percent is explained? 51%. What percent is unexplained? 49%. This is actually a pretty good, in the real world, this is a pretty good correlation.
Did
Okay.
anyone not get this?
Everybody sign the paper? Did you sign it? Okay, good. We're good. All right. Okay, so, all right. So at this point, okay, so that's all review. I want to do a hypothesis test on the slope. Okay? And the first question you should ask yourself is it quantitative, categorical, or regression? And the answer is it's regression, because slope deals with regression, right? It's regression. And it's about time we finally answered the question that way, right? Okay, we're only at the end of the semester. Okay, so now the next question is, what's the null and the alternative hypothesis? Okay, and Adam, what's the null hypothesis? Capital M equals 0. I think I might not have done that yesterday, but you should use capital M because it represents the what? The slope. We're using M. Or what else could you use? Beta 1, right? But why did I put capital instead of lowercase?
Oh, to not confuse with the lower.
To not confuse with the lowercase. What's the difference between upper and lowercase? Lowercase is the sample. Uppercase is the population. Okay? We don't know that our slope is correct, but it's a good estimate. We're inferring about it, right? And we're saying that there's no slope, right? There's no real correlation going on here is what we're saying. Okay? Now, the alternative hypothesis is M does not equal 0. Now, at the end of class, one of my actually really good students, she always asks me the good questions after class, after the camera's off. So I'm going to say her question here. Would I ever do a one-tailed test on these? I could, but I probably won't. Okay? So it is possible to do a one-tailed test, but these are typically two-tailed tests. Okay? Yes, Christopher.
So we think that our slope is 1.399.
We think our slope is 1.399.
So why is it not greater than when we think that?
Oh.
On all the previous tests, it's like we think that it's greater than.
Okay. What's my slope now?
I mean, isn't that like the first?
Okay,
step?
normally you do your hypothesis test without knowing anything about your sample. Okay, so now that I don't have that there, it's hard for me to know. And so typically, you would assume that you wouldn't know if it was positive or negative. But yes, you could argue that you think it's positive, and so therefore it could be a one-tailed test. But typically, in almost all of statistics, with the exception of the ANOVA and the chi-square test, almost all of them, all the others are two-tailed. Okay? It's a more conservative test, and you can be more sure. So, all right. Good question. Now, what's the next question? What type of test? Is it a Z, a T, a chi-square, or an F? It's a T, and how do you know? Don't know population, standard deviation. And now, she really is a really good student. And I don't know why she won't ask these questions in class. She always comes up to me after and then asks these questions. So I'm going to ask it for you. It's you, Ashley, if you're listening to this. What's the name of this test? So I'd call it a t-test for slope. Okay? Yes. Okay? So Ashley, next time you got to, class is over, you got to ask these questions in class.
This is the last class, it's not with you.
No, it's actually, well, we went long today, so we didn't cover 14.2. I was planning on covering both today. If we have time, but they asked me a lot of questions, and I don't know if you guys will. So we'll see. We might not cover 14.2 today. All right, so now what's the equation? And I didn't bring formula sheets because I didn't give you a quiz. I have 1 for me. What is it? You guys can look it up.
M1 minus big
M1 minus big M
over
S sub M1. Okay. Now, we need to figure out what S sub M1 is, right?
that is equal to S sub E over the sum
S sub E
of xi minus x hat.
of the sum of the square root of the sum
No,
of
square root completely.
xi. I don't think so.
The square root.
So here's what I'm going to say. If the formula sheet is the correct formula, if I wrote something down on the board wrong, follow the sheet. Okay? They told me that I wrote something down on the board wrong, and I don't know if I did or not. I guess I can check the tape. But whatever it is, follow the sheet. The sheet's correct. Okay?
So does the sheet say square root of the sum?
That's what I'm looking at right now. Yes, it says the square root of the sum of xi minus x bar. Quantity squared. I wrote that wrong.
So what's xi?
That's a good question. We'll answer that question when we get to it. Okay? So now we need to know what's S sub E, right?
Was this not the square root?
S sub E is, we'll go through all the steps. So S sub E is what? Square root of the sum of the residual squared divided by n minus 2. Okay? All right, so we really need to find S sub E before we can find S sub M, before we can find T, right? So this is kind of in reverse order. Okay? So how do I find the sum of my residuals squared? I could ask Ethan, but then he'd skip a step, but that's okay.
You have to get your R squared
Okay,
first,
so
not-
you'd have to get your expected or predicted value. What's the expected value? The equation, which I just moved this off. We're going to be moving this on and off. Okay, so the equation is what? Y equals 1.3991x plus 151.35. Okay, so my expected value for this first one is going to be equals what? 1.3991 times A2, yeah, 25 plus 151.35. Okay, I'm going to copy this down for all of these. Okay, and then Jessica, what do we do next? Observed minus the expected. Okay, equals the observed minus the expected. You want to square it? No, I don't want to square it, and here's why. Actually, somebody in my other class asked a really good question. And here's why I don't want to square it at this point. Because you know what he said. His name was Sean. So Sean, here's a shout out to you. Sean said, what if you did it the other way? What if you did the expected minus the observed? And I said, well, it doesn't really matter. And he said, but wouldn't it change the graph? And I said, well, it would change the graph, but it doesn't matter. Okay, and then let me explain why. Because he says, well, what about the residual plot? And I was like, oh, yes. It's another good test question on the final. I hate Sean. All right. Okay, so let's do this the other way. Let's do the expected minus the observed. Okay, so basically these are the same except for all of your signs are now backwards, right? Okay, but Sean was thinking ahead because he wanted to do better on the final. And he knew that I could ask him to do a residual plot. And if you square it now, you can't do the residual plot. Okay. Yeah, but then you'd lose the minus signs. Ah, see, so that's what you get for skipping steps. All right, so let's do this. How do you do a residual plot? We're going to digress for a minute. Scatter plot just of this, like I have here, that's actually wrong. That's what some of you did, though. That's wrong. Highlight the age column, and then we'll do this one first. Okay. Observed minus the expected. I'm going to do insert scatter plot. Okay. So that's one. Let's move that over here, I guess. So we did that one. And now this one, we're going to do the age, and we're going to do the observed minus the expected. I'm going to insert, I'm going to do the scatter, and we're going to put these side by side so we can kind of compare them. What do you think? They're just flipped, right? Now, is this a good plot or a bad plot as far as this equation is concerned? It's a good plot because it's a null plot, right? And we like null plots. What does a null plot indicate? Random error. Okay, very good. And we want to have, or I think the book uses the term constant error variance. Okay. Now let me give you an example here. And this is why I say it doesn't really matter whether you do the observed minus the expected or the expected minus the observed. Okay, so let's say that you're going along here and you get a plot that looks something like this. Okay, this is observed minus the expected. Is that a problem, first of all? Yes, because there's a pattern, and the pattern indicates it's not random error, not constant error variance. Now, if I had done it the other way, what would the graph look like? It would be upside down of that, right? It would look like this. Is that a problem? Yes. And so this is what I say. It doesn't really matter which way you do, you're still going to have a problem. Or it's going to be okay, as it was in our case. Okay? So that's why I say it doesn't matter. It matters in the sense that one's oriented up, one's oriented down. I believe this is probably the way you should do it, but it's not a huge deal.
So we're going to get dark points.
I don't think so. Okay. Now, and so that's why it doesn't matter. And now, and so when you square it too soon, you lose this because you won't get any negatives now. Okay. And so that's why it's better to do this as two steps, even though you want to skip a step. Okay? All right. So now it doesn't really matter in the sake of, let's move this down here. These are in the way. We're going back to our problem after that digression there. Okay? Okay. So now we need to square it with the residual squared. Okay, and it really doesn't matter which column I pick because the negatives are going to go away. Now what? Find the sum. Okay, I'm going to add them up. Okay, I get 4553. Now what do I do with that? Now I need to go back down here. Okay. So the sum of the so then we're going to do the square root of that number there. Okay. And n minus 2, what was my n? 14 minus 2 is, so we're going to take that divided by 12, and that gives me 5.62. Oh, actually, you know what? Let me make sure I'm doing this right. I think, oh yeah, you know what? I did do that wrong because I did this wrong. I did it wrong the first time too when somebody caught me. That was Tanner that caught me. Good job, Tanner. Okay, it's the square root of that divided by 12, the whole thing in there. So actually I did write this problem wrong, and that's why I did it wrong. The square root, maybe I'll just do it this way, slash 12. Or not, that's 12 n minus 2. So I wrote the formula wrong, and that's why I did it wrong. Okay? That's what it should be. It should be 19.48. Okay? So you divide it by 12 before you take the square root. Okay? Very important step. Now, I'm going to just take this here. Go back to what? So I take this number, I divide it by 12, and then I take the square root.
You take that number and square it?
See, Glenn, we take off a point if you leave early, though. All right. Have a good one.
Do you square it and then divide by 12?
Well, we squared each one of those, and then we added them up.
Can you just go back to the formula so I can see?
So this is squared here.
Yeah.
Then this is summed.
Yeah.
Okay. Then we take that sum, whatever we got in the sum, and we divide it by 12, and then we take the square root.
So the square root is
Don't keep squaring it. Okay? All right. Now, I'm just going to make that the numerator here. Now, I need to find my sum of my xi minus my x bar. Now, you can think of this kind of like the residuals for the x's. Okay? What's x bar in this case? It's the mean, curse Bill Gates, of that column there, which works out to be about 42 years old. So we think that the average person in here is 42 years old. Okay? Does that make sense?
So that's x high.
No, that's x bar. Okay? So now you can think of this as the residuals for the x's. Okay, so I'm going to take, and here I'm trying to decide if I should do Ethan's because I got to square it. Should we do that? This one doesn't matter. So here's what I'm going to do. I'm going to take the 25, I'm going to subtract the 42, and I'm going to square it all in one step because I don't need to plot this. And I do want to F4 the A20, very good. Okay? All right, so I can do that. Now I'm going to copy that down, and I'm going to add them up. So I get 2472.929. Does that make sense? It's going to be a fun quiz tomorrow, huh? Yeah, I can't give you 2 wimpy quizzes 2 days in a row. Today wasn't even a quiz. All right, so now, okay, so here we go. So I'm going to take the square root of that number there. Don't need to square it again, it's already squared. Okay? That gives me 49. Okay, so I'm going to take this divided by that. And that tells me my standard deviation is 0.391. Standard deviation of my slope. Okay? Now, let's think about this. Does that seem like a reasonable number to you? And how do you know? If I got a number like 15, would that be a reasonable number? No, because your slope's 1.3, right? 15 would be like huge. It would show there was a ton of variation. That would seem very unusual, right?
Yeah. So what is the standard deviation?
Standard deviation of the slope. So I mean, with a z distribution, essentially this isn't a z, but the t distribution works the same way. Okay. Essentially, what we're doing, that is a good question here. Okay. We don't need this anymore. Essentially, what we're doing here, although we're a step ahead, okay, we've got a t distribution. What do we think the mean of our t distribution is? Not yet. We don't think it's 0 yet. We think it is what? We think it's 1.3991. Because that was our point estimate, right? Now, in our next step, which we haven't done yet, we're going to convert that to a value of 0, right? Okay. But the idea here is, this is a t distribution. I want to make that super clear. It's a t. It's not a z. But let's pretend for a moment it was a z-distribution. Where would you expect 68% of, if you repeated this experiment 100 times, 68% of the time you would get a value between 1 and 1, if this was a z-distribution. You would subtract 0.39, right? Is that 0.39? Oh, that's nice, because then I could subtract 0.39, and that will be 1, and that will be 1.78. Does that make sense what your standard deviation is? Okay. Now, this is not a z, it's a t, but it's analogous. Okay, does that make sense? So does that seem like, so does 0.39, that was funny that it was 0.39. That was a big stroke of luck. Okay, does that seem like a reasonable number? Yeah, it does. Okay, all right, so now, share our screen again. Okay, so I've got a reasonable number there. Now I need to convert this from here to a standard t distribution, so I want the mean to be 0. I'm going to do that with this equation here. Okay, so what's m1? Or b1, I should say. On your formula sheet it says b1. Slope, which is 1.3991. We're going to subtract 0 because the null hypothesis is 0. And we're going to pull this number right here. So we're going to get this divided by that, which works out to be 3.57. So essentially what I've done here, I'm going to erase this. Well, I'll leave it there. It doesn't matter. Okay. Now, so we've converted this to 0. How many standard deviations am I away? I'm now 3.57 standard deviations away, right? So I'm way out here in the tail. According to my picture, that's very small. Okay? So, what's the next step that I need to do? Find the p-value. Okay? So, how do I find the p-value? Now, before I just find the p-value, I need to know my degrees of freedom. Now, by the way, this is different. Okay? Here's a hint. What is that number there? N minus 2. That's your degrees of freedom. Okay? So my degrees of freedom in this case are 12. Okay? I've got 12 degrees of freedom. My p-value is going to be t dot dist, which one? I'm doing a two-tailed test. My alternate is two-tailed. I actually should have shaded that side as well, right? Okay, so if I do two-tailed, what do I put in for x? 3.57. My degrees of freedom, 12 degrees of freedom. Two-tailed test. Luckily, that's positive. If it was negative, I'd just make it positive so that it would work for Excel. I got 0.0038. So we're saying that this area here actually, to the two-tailed test, let me correct my picture. I need to add this in here too, so negative 3.57. Between those two areas there, it's 0.0038. Okay? So therefore, Merrill, do I reject or not reject the null? Reject the null, which means the conclusion is, say it again.
I don't know.
Oh man.
The slope is not equal to 0.
The slope is there. Oh, okay, so there is evidence that slope is not just. Do we think it? We know it's different from 0. Is significantly greater than 0, right?
How do we know that?
How do we know that? What was the value that I got?
P-value is super low.
The p-value was super low, but what was the value I got? 1.3991. That's a positive number, right? We said it was significant. Even it's definitely positive. Okay. If my slope was negative and I got a p-value of 0.0038, I would say it's definitely negative. Okay? So I'm basing the fact that it's greater than 0 based on the point estimate. Okay? All right. Now, you know me by now. What would be the next question I would ask you? Confidence interval. Okay? Find a 95% confident, or an appropriate confidence interval, I'd probably say. But why did I say 95%? Because they didn't give you something, so we assume it's 0.05, right? Find a 95% confidence interval. So I look at my formula sheet, and sure enough, there's a confidence interval this time. So it's not a trick question. Okay? And the confidence interval, according to my paper, is B1, which I would call what? M, plus or minus T sub alpha over 2 times S sub E divided by, I'm just going to call this the square root of the X residuals. That's not what the formula says, but I think that makes, does that make sense to you? X residual squared. Okay.
Is it the sum of the X residuals?
What'd you say? Yeah, the sum of, yeah, sum of the X residuals. Oops. Sum of the X residuals. Okay, so all those numbers I just found, I'm going to need again. Okay. So I need to find my T sub alpha over 2. How do I find that? T dot inverse. So I could also find it on the table, right? So T dot inverse, which one? Two-tailed, right? Confidence intervals are always two-tailed. What's the probability I want to put in here?
Is it 1 minus the p-value?
Is it 0.05 or 0.95? It's what I want in the tails. What do I want in the tails? I want 0.05 in the tails, right? Okay. And my degrees of freedom, still 12. Okay, so that's 2.178. Okay. We're cruising on time here. All right, so on the lower end, so I'm going to put in here what? 1.3991 minus T sub alpha over 2 times S sub E. S sub E is 19.48 divided by the square root of sum of my X residuals, which is 2472 right there.
That was like technically X residuals.
Yeah, squared. I read it wrong, but yeah, squared. That number there. That's what we want there. Okay.
We didn't have to skip a square.
That's right. Got to be careful. All right. So now I'm going to copy it up here. I got to paste it. I'm going to change that minus to a plus. Okay. Now I'm going to ask a few different questions here. First of all, does that confidence interval feel like it's correct? Why do you say yes? Our 1.3991 is in there. Very good. Okay. Now let me ask a different question. Does my confidence interval show that my slope is significant? We vote. Who says yes? I heard a yes. 1, 2, 3, 4.5, 5.5. Is that a half? Who says no? 1, 2. Who doesn't know? Come on, more than 3, 4. Okay. How do you know? Why did you say no?
I don't know.
Because you didn't know. Why did you say no?
Because
it doesn't show if it's significant, it just shows that it's different. Like we know that so 0 is what we thought like the null hypothesis was, and so it shows that it's different, but it doesn't not show if that's significant.
Okay, you're making a distinction that's the same thing. So what he said, for those of you who are listening at home, didn't hear what he said. He says it shows it's significant. Let's see, say it again. What did you say?
It shows that it's different.
It shows that it's different from 0, but that's not significant. That's a false interpretation. If it shows it's different from 0, it is significant from 0. It's the same thing. Okay? So here's the trick. Here's the tricky part, and I know this is confusing to students. Now so Ethan did really good. Ethan did really good because he said, because I asked you if that number seemed reasonable. Okay? Now, here's the problem. On the last test, a lot of you made mistakes on your confidence interval. Okay? Now, I'm going to make a mistake, 32 to 34. Okay? Does that number seem reasonable to you? No, because 1.3991 is not in your interval. Okay? So when you're making your confidence interval, your point estimate, unless it's a chi-square, well, I don't even know how to make an F confidence interval. I don't think they exist. But chi-square you could. But if it's a Z or a T, your point estimate should be smack dab in the middle. So so 1.3991 clearly is not in there. Okay? So when you're checking that, you should be checking to see if 1.3991 is in there. Okay? Now, regardless of whether I did it right or wrong, let's talk about the 32 to 34. Let's pretend that's what I got. I did it wrong. I don't know that I did it wrong, but I got 32 to 34. Would 32 to 34 show me that my slope was significant? Yes, it would. Why? What'd you say? We got to get the volume up. It doesn't have 0 in there. Okay? So in both of these cases, 0 is not in the interval. Because 0 is not in the interval, it is significant. It shows significance. So there's two things you want to be checking. Number one, is my point estimate in there? If it's not, I made a mistake. If it is, I might have made a mistake anyway, but at least I'll feel better. Okay. Number two, I'm looking for is 0 in the interval. Okay. In this case, 0 isn't in the interval, so therefore it is significant.
So it's always significant if 0 is not in the interval.
No, that's not true because it depends on what you're doing. Okay. If I'm doing, for example, let's do this. Okay. Let's say that I'm doing my null hypothesis is mu equals 15. My alternate hypothesis is mu is greater than 15.
In that case, it's 15.
Okay, so let me see how tricky I want to make this. I'm going to try to make this tricky.
You're trying to or trying
I am
not
trying to. Okay, so I want you to really be on your toes for this one. Okay, so I get a p-value equal to, let's say 0.06. We'll assume our alpha is 0.05. I get a confidence interval of 14.5 to 16.5. Okay. This is a good one. There's going to be 3 questions I'm going to ask you. First of all, this one doesn't count as one of my 3 questions. Based on your p-value, would you reject or not reject the null hypothesis? You would not reject. That was so tricky, I think I tricked myself. Okay, so we would not reject the null hypothesis. Is there a significant difference? Or let me rephrase it. What would you conclude based on just the p-value alone?
Conclude that there's not enough evidence.
there is not enough evidence that mu is greater than 15, whatever mu represents. Okay? All right, so now let's look at my confidence interval. Does my confidence interval show significance? Yes? Should we vote? Who says yes? 1, 2, 3, 4. Who says no? 1, 2, 3, 4, 5. Did you vote twice?
No.
6. Okay. Why do you say, let's go with Adam. Why did you say there's, well, you said what?
Because mu, our null, mu is right in the middle.
Mu is 15, so you say there's not a significant difference?
Correct.
Yes, that's correct.
Is that the
Not
correct reason
a
why?
significant difference.
Is that the correct reason why?
And so why is the correct reason?
Point estimate.
Because 15 fits within here. I'm not looking for 0 on this one. Okay? I don't care that 0 is not in here. Okay? Now, let me just throw in another wrinkle because I did trick myself. Let's go back to the p-value for a minute. Let's say that it was 0.04. Now we would reject. There is enough evidence that mu is greater than 15. Okay? Let's leave this alone. We're saying there's not a significant difference. Okay? Does my hypothesis test and my confidence interval agree? They do not agree. Why do they not agree? Because why? What you said was true, but that's not why.
It's because it would have to be outside.
By the way, what she said, my loudspeaker here, said because 15 was in the interval. 15 is in the interval, that's true, but that's not why they disagree.
If there was significant evidence that it was greater than, it would have to be greater than 16.5.
Okay, so here, let me make sure. These do not agree. Okay? This one says reject. This one basically says there's not a significant difference. It says do not reject. Okay? Now, why would these disagree? I'm going to make the assumption that I did the math right on both problems. This is a rare case, by the way.
We could be greater than 15 and still within that interval. So we can be
Okay, that's a good way to say it. But so say it again loud, and I'll repeat what you said.
We could be greater than 15.
We could be greater than 15 while still in the interval. Okay. Now, so that's true, but there's a better reason. Okay. Essentially, what kind of a test is this? It's a one-tailed test. What kind of a test is this? It's a two-tailed test. Okay. So the idea here is, with this, if my alpha is 0.05 and I got 0.04, okay, I'm in my rejection region, right? So this is, if this is, we're saying that's 15. So I'm in my rejection region on here, okay? But if I were to draw the same graph here, 15, how much do I have on the right and the left side? I've only got 0.025 here, and I got 0.025 here. So this value here, well, I didn't draw this very well. It would be closer there, okay? But I'm basically in my not reject region. It's because it's the difference between a two-tailed test, which the confidence interval always is, and a one-tailed test, which my hypothesis is. So that's kind of a very rare exception where I could do the math right, but because this is one-tailed and this is two-tailed, I would get conflicting conclusions. That would be a fine line. Okay? But I have seen that on a fine line. Okay? Usually they should agree. If they're two-tailed, they almost always agree, but they could. There are rare exceptions where they wouldn't agree. Okay? So I didn't cover 14.2 today, but we did cover a lot of good, important stuff for interpretation that I hope you can do. So I'm going to post both videos, both emphasize some different things. And so Monday's quiz will be on 14.1, hypothesis tests and confidence intervals for slope, and then we'll do 14.2 on Monday. See you all Monday.